A daughter tells her mother that she will be visiting her house any day of the coming month, which has 31 days. She also asks her mother that the mother will have to give her as many grams of gold as the day of the month. So, for instance, if she visits on 5th, the mother will have to give her 5 grams of gold. If she visits on 10th, then the mother has to give her 10 grams of gold, and so on. The mother happily agrees and gets 5 gold coins made of different weights. The coins are such that they will suffice irrespective of the day the daughter visits her house. Can you tell what are the weights of those 5 coins?
You may want to pause the video, think about the solution and post your answers in the comments. So the weights are 1 gram, 2 grams, 4 grams, 8 grams and 16 grams. Let's see why. So the mother needs to achieve all weights from 1 gram to 31 grams. She will definitely need to have a 1 gram coin because that's the only way to get to 1 gram. Next, she needs to achieve 2 grams. Now she could do that by taking another 1 gram coin or she could take a 2 gram coin. If she uses a 2 gram coin, she will be able to achieve not just 1 and 2 but also 3 because 2 plus 1 is 3. Therefore, it makes sense to take 2 gram coin. Now with 1 and 2 gram coin, she is able to achieve all weights from 1 to 3. Now she needs to achieve 4. Again, to achieve 4, she could use one of the smaller weights again. So for example, she could take another 2 gram coin, but then that is inefficient. The most efficient weight is 4 grams because with 1, 2 and 4, she will be able to achieve all weights from 4 to 7. All weights from 1 to 3 using 1 and 2, 4 using 4, and then 5, 6, 7 can be achieved respectively by combining 4 and 1, 4 and 2, and 4 and 1 and 2. And now I think you can see a pattern that the weight should be powers of 2. So 1, 2, 4, 8. With these 4, she'll be able to achieve all numbers from 1 to 15. And then if you add 16, then she'll be able to achieve all numbers from 1 to 31. This puzzle makes use of what's called the binary number system, which is different from the general decimal number system we use. So in the general system we use, let's say you've got a 3-digit number like 251. Then each number is expressed as a combination of powers of 10. So this position corresponds to 10 to the power 0, this one to 10 to the power 1, and this one to 10 to the power 2. And the number itself is 2 times 10 to the power 2 plus 5 times 10 to the power 1 plus 1 times 10 to the power 0. And this is actually 251. However, there are other ways in which you can express numbers. One of these is binary number systems, where every digit can only be 0 or 1, therefore binary, and each position corresponds to a power of 2. So if we take a 5-digit binary system, so let's say 1, 1, 0, 0, 1, then this position corresponds to 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3 and 2 to the power 4. So this number is 1 into 2 to the power 4 plus 1 into 2 to the power 3 plus 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0, which is 25 in base 10. So a binary number system allows you to express all numbers from 0 to 2 to the power n minus 1, where n is the number of digits in the binary number. In this case, n is 5. Therefore, you can express all numbers from 0 to 2 to the power 5 minus 1, which is equal to 31. Therefore, mother needs to achieve all numbers from 1 to 31. She doesn't need to achieve 0. Using 5 gold coins, and whether a gold coin is kept or not kept in achieving that number can be represented as 0 or 1. So if it's 0, that gold coin is not kept, and if it's 1, that gold coin is kept. And by using these gold coins of powers of 2, she will be able to achieve all numbers from 0 to 31. Interestingly, the binary number system is how computers store all of their information, because they have billions of transistors, and these transistors can be in states of 0 or 1, off or on.
Hope you like this. Stay tuned for more such content.
Thank you.